Jai Hind everyone. My name is Amrita Bhatnagar. I am from CSE department of AKGEC. Today I am going to explain direct memory access from unit 5, which is a very good topic from COA subject. Fine. Okay, firstly we should understand what are the main topic of this subtopics of the subject topic. In this lecture we will consider about the introduction to direct memory access, how it works, DMA controller and DMA transfer. So, these are the main outline of this lecture. Fine. So, firstly we should understand what is the meaning of DMA control. So, to find out the meaning of direct memory access, we should know about the modes of transfer. What is the mode of transfer? We have three types of mode of transfer. First one is programmed I/O. In the programmed I/O, CPU always see the input output registers and check if the input output devices are ready to transfer or not. If input output devices are not ready to transfer the data, then CPU will be idle. So, this is the main disadvantage of programmed I/O. Second one is interrupt initiated I/O. In the interrupt initiated I/O, the input output devices will send the interrupt signal to the CPU, so that CPU can handle the interrupt by the help of service routine program. But this method also have some disadvantage, like it have some delay, so that there is another method for communication between the main memory and CPU, main memory and input output device, that is known as a direct memory access, DMA. The full form of DMA is direct memory access. It is used for communication between the main memory and input output device directly. So, this is the third mode of transfer. Now, we will understand what is DMA and how it works. First one, direct memory access. This is the full form of DMA, is a method that allows an input output device to send or receive data directly to or from the main memory by passing the CPU to speed up memory operation. So, this is the main feature of DMA. In this case, CPU will not interfere between the communication between the main memory and input output devices, so that this communication is fast. Second, DMA can save processing time and is more efficient way to move data from the computer's memory to other device. So, this is the best method or mode of transfer to transfer the data from the main memory to input output device and input output device to main memory. So, to perform the DMA transfer, we need a device which is known as a DMA controller. DMA controller is a hardware device that allows input output devices to directly access memory with less preparation of the participation of the processor. DMA controller needs the same old circuits of an interface to communicate with CPU and input output devices. So, DMA controller is a hardware which actually performs the transfer between the main memory and input output device, and there is no participation of CPU. Now, how it will perform? Now, the unit communicates with the CPU through data bus and control lines. Means DMA controller will communicate with the help of CPU buses. So, the buses will be transferred, which the control of the buses will have the CPU will have the control of the buses. So, this control of the buses will transfer to the DMA controller, so that it can perform the communication between the input output device and main memory. Now, we have two main signal, bus request and bus grant signal. Actually, CPU will have all the control of the buses. So, that is why DMA have to request for the buses to the DMA controller. So, that when CPU will grant the buses to the DMA control, then it can perform the operation. Fine. So, these are the main two control signal, bus request and bus grant signal. Okay, now we will see in the next slide what is the use of this bus request signal. You can see here, this is a CPU bus signal for DMA transfer. You can see here, this is the bus request signal. Bus request signal will send by the DMA controller to the CPU for all the buses. We have main three types of buses: address buses, data buses and control buses. Address buses is used to transfer the addresses from one device to another device. Data bus is used to transfer the data from one device to another device, and read and write are the control signals or control buses which send the data. Control signal or control data will be sent by the control lines. Fine. So, these are the main buses which the control of these buses will have these buses have the CPU, and this control will transfer to the DMA control when it requests the buses. When bus request signal will be sent to the DMA controller to CPU, then bus grant signal will be sent by the CPU to bus grant signal. Now, what is the meaning of bus grant signal? When all the control of the buses will be transferred to the DMA controller from the CPU to DMA controller, then it is known as a bus grant signal. Okay. When bus grant signal's value is 1, it means the control over the buses is on the DMA controller by the DMA controller. Now, these are the main three modes where it when this DMA controller will work. These are the three mode: burst mode, cycle stealing mode and transparent mode. In the bus mode, here once the DMA controller gains the charge of the system bus, then it releases the system bus only after completion of data transfer. Till then CPU has to wait for the system buses. Okay, which I have discussed already. The buses will be transferred to the from the CPU to DMA controller by the help of two signals. First one is bus request and bus grant signal. When DMA controller have all the control on the buses, then it will send all the data transfer, and after the completion of the data transfer, the CPU buses will be returned to the CPU. And this mode is known as a bus mode. So, first one is the bus mode, and it is very useful because it will save the time because all the data will be transferred in one time. Second one is cycling stealing mode. In this mode, DMA controller forces the CPU to stop its operation and relinquish the control over the bus for the short term to DMA controller. After the transfer of every byte, the DMA controller releases the bus and then again requests for the system bus. In this way, DMA controller steals the clock cycle of transferring every byte. What it means, in cycle stealing mode, only one byte will transfer at a time, and after the transferring the one byte, again the control will be transferred to the CPU. But it is very time consuming. After the every byte, we DMA have to send the buses, return the buses to the CPU. So that this mode is not very useful. Next one is transparent mode. Here the DMA controller takes the charges of bus only if the processor does not require the system bus. Okay. So, in this case only when CPU not require the buses, then only DMA control will have buses, otherwise it will not have buses. So, these two modes are not very useful, but bus mode is very useful in the case of DMA controller. Now, we should understand what is the meaning of DMA controller. DMA controller needs the user circuit of interface to communicate with CPU and IO devices. We have three registers in the DMA controller. First one is address register, second one is word count register, and third one is control register. Fine. Okay. When the DMA will start the communication between the main memory and input output device, there is a method of DMA initialization. DMA initialization means there should be some knowledge transfer between the CPU to DMA control. It means CPU will transfer some knowledge or some information about this transfer to the DMA, so that it can perform easily this task. So, first one is the content of the address register, second one is the content of word count register and control register. Now, what is the meaning of these three registers here? Address register contains the address to specify the desired location in memory. For example, when we transfer the data from the main memory to input output device, so at which location we have to send the data, from what is the initial address of the desired location, so that this the CPU will provide this data or this address location to the DMA controller before the transferring the control of the buses. Second one is the word count register. Word count holds a number of words to be transferred. For example, if main memory transfer the 5 words from the main memory to input output device, it means the word count register will have number of value in this register is 5. Okay, and when all the transfer will completed, the value of the word count register will become 0, because it decreases after each transfer. Okay, so in this case, word count register will have the number of words which we want to transfer. Okay, so this is the another information which CPU will provide to the DMA controller. And next one is the control register. Control register specifies the mode of transfer. The unit communicates with the CPU via the data bus and control lines. The register in the DMA selected by CPU through the address by enabling data select and RS register inputs, and RD read and write inputs are the bidirectional. Okay, so in this case, control register read and write information will be provided by the CPU to DMA controller. It should be, it is read information or it is a write information. The control register will have control information. Now, when the bus grant is equal to 1, the DMA can communicate directly with the memory by specifying an address in the address bus and activate the read and write control. So, to activate the read and write control, the value of bus grant should be 1. Okay. So, when the bus request will be sent by the DMA controller to the CPU, then CPU will initialize the DMA controller. It means it will send some important information related to the transfer to the DMA controller. Then it will activate the bus grant signal 1 and grant all the buses control to the DMA controller. Then DMA controller can start the transfer, direct memory access. Now, we should understand what is the DMA controller, DMA transfer. Now, we should understand what is the meaning of DMA transfer here. You can see here, this is the input output devices and this is the random access memory or main memory. The main transfer should be here from the main memory to the input output devices. Now, what will happen? How it possible by the help of direct memory access? Firstly, input output device will send a DMA request to the DMA controller. This is the hardware for DMA transfer. Okay, we will discuss about the DMA controller afterward. What is the content or what is the main units in the DMA controller, but firstly we should understand what is the DMA transfer here. The firstly, input output device will send the request to the DMA request to the DMA controller. Now, when direct memory access or controller see the DMA request here, it will start working and it will send the BR or bus request to the CPU. Fine. When bus request sent by the direct memory access controller to the CPU, then what will happen? Then CPU will relinquish or send the control of the buses to the direct memory access. But before the sending all the control to the direct memory access controller, it will initialize the DMA controller. It means it will send some important information to the direct memory access or controller. So, firstly what it will done? It will done DMA select and register select. Firstly, it will, by the help of this address select, CPU will select the DMA chip by the help of DMA select. When DMA select will be active, then this DMA controller will be active or selected. Then the process will start when the DMA select will selected. Fine, the value of DS will be 1, and after that we have a register select. Register select will registers from the direct memory access. We have 3 registers here or other components also there. So, select the particular register, we have register select here. So, by the help of DMA select and register select, we will select DMA and register from the DMA controller. Fine. Now, when this DMA controller will selected, then the important information of the CPU will send by the CPU by the help of these buses, because this time CPU will not active this bus grant signal here. So, control of the buses will have CPU will have all the control of the buses, and so that CPU can transfer the some initial information to the DMA controller. Initial information means the initial address of the memory or particular input output device where the data will be transferred or from the data will be transferred, and second one word count, number of word which is to be transferred, and other information is read or write information. So, these main three information will be sent by the CPU to the DMA controller, and this process is known as a DMA initialization. Okay. So, when CPU will get the bus request, it will initialize the DMA, it will select the DMA, then it will initialize the DMA and send some important knowledge, or you can say some important data to the regarding the transfer to the DMA controller. When it will get the information, the DMA controller get the information, then CPU will send the bus grant signal to the DMA controller. When the bus grant signal is activated or the value of bus grant signal is equal to 1, it means now the control of the buses will be transferred to the DMA controller. Now, CPU is not participated in the communication between these two devices, input output device and random access. Now, this DMA controller will send the DMA acknowledge. Okay, when it gets the bus grant signal or when it gets the control of the overall buses, then it will send the DMA acknowledgement to the input output devices. Fine. Now, communication will start and main memory and input output device will directly send the data or transfer their data without the intervention of CPU. So, this is the process of DMA, and now all the control will be handled by the DMA controller. Now, when for example, if we want to transfer the data from the RAM to input output device, then 5 words will be transferred from the RAM to input output device. Now, after the completion of data transfer, what will happen? Now, DMA controller will send a interrupt signal to the CPU to give the information about the completion of data transfer, because now the data transfer is completed. Now, there is no requirement of buses to DMA. So, DMA will transfer the control of the buses to the CPU again. So, to inform the CPU, it will send an interrupt signal and send the control of the buses to the CPU again. Fine. So, this type so that we can say now the DMA controller completed its work and transfer the bus control to the CPU again. Fine. So, in this way we can transfer data transfer from input output device to memory directly without intervention of CPU. Now, we will see the main circuit of the DMA controller, how we can this DMA control will perform. This is a circuit for the DMA controller. You can see here, this is the address bus buffer, this is the address register, and this is the word count register and control register. And you can see here, this is the control logic, where we can see here control signal read and write, bus request, bus grant, interrupt. Bus request is a signal which is sent by the DMA to the CPU to find out the control of the buses. Bus grant signal will send by the CPU to DMA when it transfer the control of the to the DMA controller. Read and write signal are the control information. Data select, these are the two signals which is very important, DMA select and register select. When the value of DMA select is 1, it means this chip of DMA is selected. Fine. So, CPU will use address select to select the DMA select. So, when the value of DS or DMA select is 1, it means DMA is selected. Now, after the DMA selected, what is the next value should be 1? This is register select, because we have these 3 important registers, so that this is selected by the register select signal. So, this is the main control logic in the control DMA controller. Now, there is a data bus buffer, where we can store the data for the temporary purpose. This is the address bus buffer, where we can store the address for the temporary purpose, and you can see here, this is a DMA request and DMA acknowledgement signal. DMA request signal will be sent by the input output device to the DMA, and when the DMA gets the control of the overall buses, then it will send the DMA acknowledgement to the input output devices. Okay. So, by this diagram, you can understand what are the main component of the DMA controller. So, okay. Now, DMA transfer. The CPU communicates with the DMA through the address and data buses as with any interface unit. The DMA has its own address which activates the DS and RS line, which I have already told you. This is the DS and RS line, by which by the help of this line we can select, or CPU can select DS and RS line and DMA controller. The CPU initializes the DMA through the data bus. Once the DMA receives the start control signal, it can transfer between the peripheral and memory. Okay. So, there is a process of DMA initialization before the DMA transfer. When the DMA initialization is completed, then bus grant signal will be sent by the CPU to the DMA controller. When BG is equal to 0, the read and write input lines allowing the CPU to communicate with the internal DMA register. When the value of VG is equal to 1, the read and write are output lines from the DMA controller that access memory to specify the read and write operation of data. It means when the value of VG is equal to 0, it means CPU can send the data by the help of buses to the DMA or to the DMA register. But when the value of bus grant is equal to 1, then CPU cannot send the data, because now the control of the bus is transferred to the DMA controller. So, now CPU cannot send the data to the CPU to DMA controller. So, that when the value of VG is equal to 0, then only CPU will initialize the data. It means it will send the important data to the DMA controller, and then it will activate bus grant signal 1. Okay. So, and by the help of, I have already explained how this DMA transfer will perform. I think Now you have understand what is the use of DMA controller and DMA transfer and how it is very beneficial for the input output devices and random access memory transfer. Thank you.